Okay, let's have a look here. Right, we want the cube roots of unity. I think the quickest path here would be to factorize z cubed minus 1, z minus 1 times z squared plus z plus 1 equals 0. So that means z equals 1, or z equals minus b plus or minus the square root of b squared minus 4ac all over 2e. So we have the roots are 1 omega 1, which equals minus 1 plus or minus I root 3 over 2, and then omega 2 equal, oh yeah, sorry, we'll take that one as the plus 1, and then minus 1 minus I root 3 over 2, and we have to show that omega 2 equals omega 1 squared. So omega 1 squared would be all over 4, the first squared, and then twice the first by the second, plus the second squared. So that's minus 2 root 3 over 4, which is minus 1 minus root 3 over 2, which is omega 2. Hence or otherwise show that 1 plus omega 1 plus omega 2 equals 1 plus minus 1 plus I root 3 over 2 plus minus 1 minus I root 3 over 2, which will equal 2 minus 1 plus I root 3 minus 1 minus I root 3 all over 2. They cancel. 2 minus 1 is 0 over 2, which is 0. Okay, that's part A done. Part B, maybe I'll shrink this down a little bit. Right, clearly indicate on the Argand diagram in the Z plane that's set there. So that's located. This I prefer to write this as Z minus 1 plus 0i, more than or equal to 1 and less than or equal to 2. So what you have here is a circle positioned at minus 1 plus 0i. And this circle has a radius of at least 1, so it'll be like that, but at most 2. So it's a circle here, and this here, that's minus 2. And that's minus 1, and that's 0, and that's 2. Did I do that right? Oh, sorry, no. The radius is 2, and that's minus 3. That's minus 2 there. That's 0. So 1, 2, yeah, that's it, okay. And that is called K. Now, I usually draw it on the same diagram, but this time I'll do it on a separate one. I'll draw it on a separate one. So then we have the transformation. So let's see what the transformation does. It takes Z, and then it multiplies it by 3. Then it multiplies it by minus 1. And then it adds 1 to it. So if we started here at, let's look at what happens to the center. It started here at minus 1. So if I triple it, it'd be out here to -3. And the center wouldn't care about the minus here because that flips it upside. Oh no, it does care. It flips it through the imaginary axis. So now it gets flipped over here to be at 3. And then you add 1 to it. So now it's here at 4. Okay. So I'll just call the center C. So C is here. And then let's take this point here. So it was at 1. So maybe actually I color coded. So the center there. Okay, and let's track now a point on the circumference, the origin. So starts here, multiply by 3, still here, minus, still here, add 1, now it's here. Okay, and then let's track this point here, 1. So we start at 1, multiplied by 3, we're at 3. Oh, yeah. The minus doesn't affect the last one because it was at 0, sorry. Start at 1. That's 1. That's supposed to be a 1 there. Okay. Right. So start at 1. And then multiplied by 3. So we're at 3. And then minus it, we're at -3. And then add 1, we're at -2. So it looks like if that's the center, that was the inner, that's the outer, it's going to look like this. Kind of gone off the page. That's f of k. So it's bigger because of the 3. It gets flipped through the y-axis, but that doesn't change much because if those two guys move to the left, it's still a circle. And then it gets translated to the right 1 unit. So it's bigger and to the right and actually flipped around, but you can't tell. Yeah. Okay. Okay. I think that's it.